right? All of you keep the side heading as AC through pure capacitor. Later we will go for inductor followed by capacitor. So out of three, these are three R, L, and C. Which elements are energy storage property? The
C,
energy
sir. Capacitor.
capacitor, which can stores energy, right, in the form of electrostatic energy, right? And what about inductor? What about inductor? What is the energy stored in capacitor formula?
Half
Half,
C square.
half CV square. Good. And what about inductor?
Half L square.
Right. That means inductor, which stores energy in the form of electromagnetic field. That is how much? Half L I square. And what about resistor? Is resistor going to store energy or going to dissipate energy? Heat dissipative?
Dissipate energy.
Right. Very good. It is a heat dissipative element. Good. Very good. So now we will go for resistor. Here I am taking one resistor and connecting 1 voltmeter across that. The amount of current which is passing through it and the amount of voltage we applied, V of t, I of t, and capital R. Right. Now we need to draw the phasor diagram for this resistor. So how these V and I should be getting connected, either in phase quantity or out of phase quantities? I think that concept is over, in phase quantity and out of phase quantity, right? See, here I will give one example. Not even directly, we can go for the curves. Here first I will go for your basic fundamental, that is what we learned for the phasor representations, that is in form of signs. Later we will move on to the vectors. Once if you are proficient with sinusoidal, then I will move on to vector representations. Your V and I. On x-axis omega t, right? On y-axis it should be voltage and current, right? So what is V of t? V of t is nothing but
V omega.
sin omega t. What is the phasor angular difference between V and I? Is there any angular difference presented?
No.
No, right? We know the formula of I as V by R, right? We know the formula of V because what we applied is sine. Vm sin omega t by capital R. So what is the angular difference? Sin omega t plus 0, right? So that means what is the angular difference value here? The phi value is
0.
0, right? Right. So 0 in the sense V and I are in phase or out of phase?
In phase.
In phase quantities. And what is the angular difference between them is?
0.
0 degrees. If it is 0, either you can take representation as either theta or 0
Pi.
pi. What about your power factor?
1.
Right, cos 0 is 1. That is unity. So for resistive loads, nothing but R loads, the power factor is always unity. Very important for competitive exams. That means 1 power factor. So will you represent the same in the vector form? That is vector form, instance you need to take one reference, the reference here and considered as a V, and therefore the another parameter which is varying with respect to voltage was current. So this is your origin. So current which is also in phase quantity. So shall I represent like this? Your I. So the angular difference is only 0 degrees between V and I. So both are in phase quantities. Right, understood? If we move on to the pure inductor, then you will have some more clarity. Next, keep the side heading as AC through pure inductor. AC through pure inductor. What is the property of inductor? Can anyone tell me the property of inductor quickly? What is the property? The most important point. What we study?
Opposite change in flux, sir.
It will oppose
Change in flux, sir, or
change in
current.
flux. Right, very good. It will oppose sudden changes of current. Right. Now, sudden changes of current opposition, nothing but which one is leading, which one is lagging. So out of these V and I parameters, which parameter is leading, which parameter is lagging? How should we come to know that? That means, for example, take an example of your tube light. There should be existing some choke, right? Some inductor. So when you switch on, the socket voltage 230 is applied, right, to the tube light across that, and some amount of current starts to flow that, and the voltage is already presented there. And what is the later followed parameter after voltage existence? Current. Right? In the same time, is it allowing the current to pass through that? Able to understand?
No, sir. Repeat again, please.
So let us take, you are having in your home the tube light, right? When you switch on that tube light, right? So what is going to happen? The socket voltage of 230 volts applied across the tube light, right? The input voltage.
Yes, sir.
So during that
Hmm.
time, what should going to happen parallelly? The amount of proportional to current starts to flow through the tube light. So is that choke is allowing immediately or taking some time period to allow that?
Taking time.
Time period. So that means what is the first parameter which is already existed there and which one is coming late?
Current is coming late.
Late.
Current.
Right? Voltage is earlier, it's present, but current
Yes, sir.
coming late. So that means shall I conclude that as current lagging the voltage in the case of
Yes,
inductor?
sir.
Because
Yes, sir.
inductor property itself is it won't allow sudden changes of current. So that's why voltage will be presented as usual, but current will be late. So shall I conclude the statement as current is lagging the voltage in the case of inductor?
Yes, sir.
Right.
Yes, sir.
So now how much angular difference? We know if it is lagging, I don't want to draw again the sinusoidal waveforms. So directly I'm going for the vector phasor representation in vector format. That is the reference as V, and the current is lagging now, right? If it is a pure inductor, so lagging in the sense pure inductor is 90 degrees exactly. Right now current is lagging with respect to voltage. Clear now? Understand how the vector diagram, phasor diagram is drawn?
Yes, sir.
Now we will check for how this 90 degrees we can obtain, right? We can check once in our basic fundamentals. For your understanding, I am telling this. We know that V of t equal to Vm sin omega t,
Sin omega
right? And the voltage present
plus
across
pi.
the, right? And the voltage which is presented across the inductor. What is the formula of voltage presented across the inductor? VL equal to, in our unit 1 we have it, voltage across inductor.
L into di by dt, sir.
Very good. L into di by dt. So here, what is VL is nothing but your V, simply, right? This is your V, that is V of t, nothing. What is the presented voltage across your inductor? Now, di by dt is equals to V by L, right? So, ma, my voice is clear to everyone?
Yes, sir.
Right, fine. If anyone having any noise disturbances or low level of voice, if you are unable to understand, you can check once your network issues and relog in, right? Because
Okay, sir.
I received only one member in the chat box, right? Audio issue. So I think it may be at your side. You can check once. And d by dt is equals to V by L. And
V by L.
that V value is Vm sin omega t
Vm sin omega t.
by L. So shall I get the value of I by taking the integration of this?
Yes, sir.
So what is the integration of Vm is a constant, so I am writing Vm outside, and L is also constant, I am writing outside, and sin omega t d omega dt. Sin omega t dt. So nothing but we can write what is the integration of sin omega t dt, cos omega t by omega, right?
Minus t.
Sorry, minus, very good. Minus cos omega t by omega. Good. Sin theta minus cos theta, correct. So now Vm by omega L and minus cos omega t, shall I write like this? Sin omega t minus 90,
Yes, sir.
right? Both are same. Sin theta minus 90. Nothing but sine of minus of 90 minus theta, that is minus cos theta, right? So therefore, what is the value of phi now? Minus 90.
Minus 90 degrees.
So is it clear now? 90,
Yes, sir.
the angle of phi. Why should I draw exactly 90 degrees for ideal inductor, right? And this omega L, shall I replace that omega L with XL, inductive reactance,
Yes,
right?
sir.
You know very well, XL equal to omega L and XC equal to 1 by omega C,
Omega c.
right? So here I equal to Vm by XL into sine of omega t minus 90, right? Understood until now?
Yes, sir.
So shall I again further refine it as Im sin omega t minus 90? So where Im is
Yes,
nothing
sir.
but
T
Vm
by
by
R.
XL. So all are correct. Okay. You can stop up to here in your examination. You can get full marks. Or else you can also refine it to furthermore by mentioning Im value also, where Im equal to Vm by XL. That should be useful for our numericals problems. So here, how can I conclude this statement of AC through pure inductor? The relation between V and I, always V leads I by 90 degrees or some angle phi. Or shall I rewrite this one is again like I lagging V? So in some textbooks, you may get your statement 1. Some textbooks, they mention statement 2. Both are correct. Okay. The voltage leads current by 90 degrees, or the current lags V by 90 degrees. Understand? AC through pure inductor.
Yes, sir.
So will you go for capacitor by your own? Shall I erase the screen? All of you noted? If completed, I will move on to next topic, that is AC through pure capacitor.
Yes, sir.
207, 206, 206, Dhanush, 207, 209,
Completed, sir.
completed, okay, fine. 207, are you present?
Yes, sir.
Done, noted?
Yes, sir.
Okay, fine. 206, Dhanush. 240, 240.
Yes, sir. Completed.
Completed? Okay, right. Next, to keep the side heading AC through pure capacitor. AC through pure capacitor. One second. Right. AC through pure capacitor. Right, AC through pure capacitor. And all of you draw the circuit diagram. Capacitor, which is how the voltage should be getting connected across the capacitor. The capacitor where we are connecting the voltmeter across that, the value should be V of t. So V of t is nothing but Vm sin omega t. And the amount of current
Sir,
is
not
passing through
that
the.
it seems, sir.
Sorry, ma? Can you repeat again?
Let her in.
Okay. 207 in waiting room. Okay. Why I think she is in the class itself? Okay, fine. Right. So the capacitor where we are connecting across one voltmeter we are connected, and the amount of current which is passing through capacitor as I. Now tell me which one is leading, which one is lagging in the case of capacitor.
I I is leading, sir. V
Right.
is lagging.
Good. Because the property of capacitor is, what is the property? What is the property of capacitor? Leading in the sense positive.
Does not allow sudden changes of voltage.
Right, it does not allow sudden changes of the voltage. So therefore, it does not allow sudden changes of voltage means where voltage is lagging with respect to the current parameter. Now we will check how the current parameter of plus 90 will be coming, the angular difference between V and I. Okay. So what is the value of current passing through capacitor formula? I equal to C into
C into dV by dt.
dV by dt. Very good. We know the value of V as Vm sin omega t. So take differentiation, that is C into Vm omega cos omega t, right? Correct. I am writing directly d by dt of Vm sin omega t. So for that, sin theta cos theta, that coefficient omega is outside. Right. Now, shall I refine that as Vm by 1 by omega c into
Yes,
cos
sir.
omega t? So because that should be now easy for me to replace with xc.
X-ray.
Right. Now cos theta, shall I replace that with sin omega t plus 90? That is sin 90 plus
Yes,
theta, cos theta. Right. So this is your value of I and plus 90, the angular difference. How is it clear to all of you? If you take it as a vector, it should be I at an angle 90 degrees. So what is the conclusion statement for capacitor? V and I, they are in out of phase, and always current
lead.
lead into it by some angle phi. Here it is 90. Similarly, ORR, we can also rewrite that as V lags phi by 90 degrees. Clear, all of you understand the RLC. Here, what is XC value? Where XC is equals to capacitor
1
reactance.
by omega c.
Right. What is omega? Further, omega is nothing but 2 pi F.
L.
So XC or XL, what we are obtained in earlier derivation, that is XL, here XC. So these XL and XC, where XL is the inductive reactance and XC is the capacitive reactance.
Capacitor react.
Right. What are the units for XC? Simply these are ohms, because this is
Frequent.
reactance. Reactance in the sense nothing but which can oppose the flow of current, like your resistance, but this is an imaginary quantity. Okay, like Z equal to R plus Jx, where X is nothing but either it may be XL or XC based on inductive reactance or capacitive reactance. That is imaginary term. And your R is real term.
Real.
That is your resistance, and X is reactance. Both units are ohms only. Units are ohms, units are ohms. So what are the units for your Z? That is impedance. Both units are ohms means for impedance also the units are ohms. So what is the property of resistance which can oppose the flow of current? Similarly, the property of X is also which oppose the flow of current. So therefore, what is the property of impedance which can oppose the flow of current? Understand? Here the only difference is one is a real term, another one is imaginary term. The final one is the complex term, that is Z. Understood now? The impedance R, X and Z. If anyone asking you the magnitude of impedance, that should be under root of R square plus X square, where X may be XL minus X,
After plus X square.
right? XL minus XC, the total. If you take the RLC, we can check.
XC.
We can check later for the combination circuits. Note it down quickly, and then we will move on to the combination circuits. Combination circuits in the sense, so we can mix both parameters R and L in the same circuit.
RL.
Okay, now up to now we
Okay.
seen that individual components, resistor, inductor, capacitor. Now we will shift to the combinations RL, RC. Okay, like that. Series and parallel combinations, both we will check all the probabilities. So quickly complete it. All of you done?
Yes.
Right. Next side heading. RL circuit. RL circuit. RL circuit, which is excited by sinusoidal source. RL circuit, which is excited by sinusoidal source. Right. Under that subheading, RL series circuit. RL series circuit. So all of you focus very carefully for 2 minutes so that the remaining you can draw by your own. So RL in series in the sense R, L, both are connected in series across the voltmeter, which is given as AC supply, that is V, and your R parameter and L parameter, the voltage which is presented across the voltage drop VR and VL. All right, this is your total voltage V, and now we need to draw the phasor diagram. See here, there are two factors. Here I will mention the current also, I bar. So now you may have the reference vector to draw the phasor diagram. The reference here I am considered as current, as capital I. Now go for individual first. For resistor, VR and I. You need to compare it with VR and I. Now for resistor, voltage and current are in phase or lead or lag. Tell me, for resistor, V and I are in phase, are any lagging or leading conditions? Just now we finished RLC individually. In that individual parameters, if you consider the resistor, which is excited by some voltage source and the current passing through as capital I, now V and I are in phase or any relation, lagging or leading?
In phase.
In phase, very good, no, very good. Which are in phase quantities for resistor. So that means, shall I mention VR here? Right, the voltage present across the resistor. Now the resistance part is finished. Now we will move on to inductor, right? So for inductor, is that my mouse pointer is visible to everyone? That arrow mark?
Yes, sir.
Okay, fine. Now for inductor, now we need to draw the phasor diagram for inductor. So for inductor, again, see here, current is remains same in series circuit, right? I is remains the same. The current passing through resistor and current passing through inductor, both are remains the same. So that's why again I am considering I as a only reference parameter for drawing a phasor diagram for inductor. Now here this is not a pure inductor and a pure resistor, so it may be having some angular difference of phi. If you consider these are the pure resistor and pure inductor, then you may go the same as we discussed in earlier. That is, for inductor, what is the relation between V and I? For inductor, what is the
E
relation?
equal to Li to di by dt.
No.
L into di by dt.
Phasor. In phasor diagram, are they in phase or lag or lead for inductor? V and I. Always in inductor, current leads or voltage leads. What is the relation between voltage and current?
Voltage leads current.
Voltage leads current. right? For resistor, V and I are in phase, and for inductor, voltage leads current, right, by 90 degrees. So here, now voltage leads in the sense I need to draw the curve to positive y-axis or negative y-axis for VL with respect to input,
Right.
right? Positive 90 degrees because voltage leads VL. Here that is VL bar. Simply VL at the rate of 90 degrees. Understand up to now? Now, what is the resultant vector? So shall I draw the resultant vector from this? Right? Now, what is the resultant vector? Capital V. Understand now what is the equation for capital V? VR plus VL. Sorry,
Real.
I'm getting some background. Bhargav, I hope you are having some background noise. Right. So V bar is equals to VR plus VL now, right? So that means the first, that is VR, should be having with an angular difference of 0 degrees because this is in the case of a resistor. And in the case of inductor, it should be at an angle 90 degrees. So shall I simply conclude that VR plus JVL, because 90 in the sense J. So V is equals to VR plus J into VL. Now will you write the magnitude value? V is equal to under root VR square
Yeah, square plus VL.
VL square, and the angular difference are directly I can write here. V is equals to under root VR square plus VL square at an angle tan inverse VL by VR. Then understand now the resultant voltage value. And this again further we can refine that as, from this you can note down. So here V is nothing but total, that is, shall I write as IZ, that equals to, what is IZ in the sense I into R, that is VR. VR is simply, I will take new slide. One second, I will take new slide. Right. So what we are having now, V equal to VR plus VL. So V is nothing but I into Z, that is a total voltage. That means total current into total impedance of the circuit. And what is VR? I into R
IR.
plus what is VL? I into X
L.
at the rate of 90
XL.
degrees. This one is 0, this one is 90. So that equals to, shall I make it common as I value plus R plus J into XL, that is I into Z. So I will be getting cancelled. What is the value of Z now? R plus J XL. Understand now the value of Z, that is impedance. The total impedance of the circuit for RL series circuit is Z equal to R plus J into XL. If anyone asking you the magnitude value, what is the magnitude value? Determinant of Z equal to under root
R square plus XL.
plus X square, where XL is nothing but omega L. Where XL is equals to omega L. Clear up to now? Done. So what are the conclusion points for this? The voltage V in the case of resistor, in this RL circuit, in the case of resistor, voltage and current are in phase. right? In the case of resistor, V and I in phase, we drawn that. And in the case of inductor, V leads I by 90 degrees. Clear, understand now? These 2 points are very important to draw the phasor diagram for series RL circuit. Understand? Just to check once, I will revise it. Right, okay, thank you. So RL series circuit, that is where we need to draw the circuit as both resistor and inductor in series combination, right? Here this one is figure 1. That is, we are connected one voltmeter across this series combination of RL, because what the main heading is RL circuit excited by sinusoidal source. So here I am excited with a sinusoidal source and some amount of current is passing through series combination of R and L. Now we need to draw the phasor diagram for this series RL circuit. So this is a series circuit. Which parameter is common out of voltage and current? Obviously it should be current. Current is constant. So that's why always remember the reference parameter should be a constant one. That constant parameter only we need to consider as a reference in phasor representation. So in this phasor diagram, I taken the reference as your current, because current is same for both R and L, because they are connected in series. So therefore, first I need to draw for a resistor, that is the relation between VR and I. For resistor, we know already that V and I are in phase. So immediately VR should be in phase with the reference I. And then the next component which is presented in the circuit is inductor. So inductor, so therefore inductor in the sense always current lags or voltage leads. So therefore voltage is leading, VL is leading with respect to the reference I by an angle some 90 degrees. And I considered as a resultant vector by using of this VR and VL, the resultant vector should be V bar. So therefore we know that as per our mathematics, V bar is equal to VR plus VL, and VR should be making an angle of 0 degrees with your reference axis, and VL should be making it an angle of 90 degrees. And by substituting that, what we obtained as our net resultant voltage, that is VR plus J VL. Now, so from this, where I replacing the voltages with respect to their drops, that is IZ in the place of total voltage, and in the place of voltage present across resistor as IR, and voltage present across the inductor as I into XL. So by substituting all, we obtain the impedance of the total circuit. This is the impedance of total given circuit, that is RL circuit, RL series circuit. Right, if anyone asking you the angular difference, that should be tan inverse XL by R, and the units are ohms. Finish up to this. Having any doubts for RL series circuit? Will you able to draw the phasor diagram by your own by considering the individual component R and later with L? Understand by everyone? Quick response. Chat box, they are typing. Okay, no, fine. What about remaining all? Some of them are typing in chat box. The remaining 224, 25. Both names are same. Manisha and Manish. Okay, Manish. 225. And oh, okay. Chat box, mic problem. Okay. 212. Bharadwaj. Done. Having any doubts? 29. Suras.
Yes, sir.
Finish. Completed. Understood. 223. Abhilash and 203 Satish. Quickly refer parallel. I will take the new slide. 10 minutes break. No break now. So we will finish out in 2 minutes. Wait for 2 minutes. RL parallel circuit. I too have the another session for 3rd years. So now we drawn the RL parallel circuit, both R and L in parallel combination. Right, we are applying some voltage V across the parallel combination of R and L. The amount of current which is passing through, that is I. Therefore, these are in parallel connection. There is some division of current, that is IR and IL to the both branches. Now tell me which one I can take the reference, either voltage or current. For phasor,
Voltage.
voltage, very good. Why voltage? Because voltage is constant in
Voltage lag.
parallel. Voltage is constant in parallel combination. Whereas
Constant.
in series, what we constant is current is constant, so that we consider as current in series circuit. That is in last circuit. Now the parallel connection, so therefore voltage is constant. So the constant value should be always considered as a reference parameter. So here the reference parameter is voltage, since it is a parallel circuit. Now we will move on to for individual resistor. Now the first point is in resistor. What is the relation between V and I?
Phase.
In
In
phase.
phase.
Right. Now don't see the circuit and making yourself confusion. Just answer my questions. So V and I should be in phase. That means IR and V both are in phase, and the angle of difference is 0. Now in inductor, what is the relation between V and I?
V leads.
V leads
I by
90, or I lags V by
lag.
90. So lags in the sense we need to draw downward. That is IL. So shall we draw the resultant of total current I? So I bar is equals to IR plus IL. IL is nothing but at an angle 90 degrees. Clear, understand? That is minus 90 here, negative. Now shall we do the simple analysis? I bar is equal to IR plus IL at an angle minus. IR is simply 0 degrees because this is a resistor. Right? Now I bar is equals to IR minus J into IL minus J, because this is minus 90. Clear? Now shall we draw in both magnitude and angular format? IR square plus IL square at an angle tan inverse IL by, sorry, minus IL by IR. Done? All of you noted? Completed, all of you?
Yes, sir.
Yes, sir.
Now RL series and RL parallel circuit, any doubts? RL series and RL parallel circuits, any doubts you are having? No? Now this is for your homework for RC series. Will you try to draw this? R, C and V and current passing through that of T, the voltage drop VR, VC, and what is the reference vector we need to consider here? Which parameter is the reference value?
Current.
Current. Why?
Constant.
Right, because this is a series. So where current is constant. And quickly tell me in resistor, V and I are
In phase.
in phase. So where should I mention V are? Right, in phase quantity. Right. For capacitor, what is the relation between V and I?
V lag.
Always V lags I by
I 90 degrees.
So V lags I means we need to draw downward. That is your VC, and the resultant. What is the value of resultant now? V bar, right? Where V bar is nothing but simply VR bar plus VC bar, that is minus 90. Here this one is 0 degrees. So shall I simply conclude that as minus JVC, right? Or else you can simply, in terms of if drops, if you wanted to write, that is IZ equal to IR plus IXC at an angle minus 90. Right, done. So shall I simply write this as IR minus JIXC? So by taking I as a common factor on left hand side, right hand side, R minus JXC, right? That is our total impedance for RC series circuit. See, all of you are able to draw by your own. Easy to understand how to draw the phasor diagrams.
Yes, sir.
Right. So now will you draw for RC parallel circuit by your own? RC parallel. How resistance and capacitors are connected in parallel combination. Voltage and the current. Here it is a junction point. It is dividing as IR, IC, right? So what is the reference value now?
Voltage.
Right, it should be the voltage. Good, very good. So our first point in resistor, V and I are
Phase. Or in phase.
in phase. So in phase in the sense your IR, we need to mention IR, right? Then in the case of capacitor, always voltage with respect to current.
Lag. I by 90 degrees.
Right. V lags I by 90 degrees, or I leads V by 90 degrees. So I leads in the sense IC here, capacitor current. So IC leads by 90 degrees with respect to voltage. Now the reference vector is total current. That is IR plus IC, 10 angle 90.
Sir, we have maths class, sir.
Yes, mass. It's over. It's finished. Your RL and RC circuits. Now it should be done. Any doubts till now? Your RL and RC circuits. So once you get back, I will share the recording. So quickly go through that once again and practice more. In tomorrow's session, we will go for RLC circuits. Okay, RLC circuits. So can anyone posted your attendance in our group quickly?
Posted, sir, already.
Already posted. Good, good. Okay, now fine.